Hello everyone, welcome back to the channel. If you're watching this video, I'm assuming that you have already seen part 1 of the DESMOS series, where we have discussed the key approaches and the strategies for using DESMOS efficiently on SAT. In part 2, we are not talking theory anymore. We are jumping straight into the practice. I'll be solving 5 SAT style questions live using DESMOS so you can see exactly how you think, click, and interpret the graphs in real time. Make sure you have DESMOS open along with me. Pause the video whenever you need and try each question yourself before I solve it. All right, let's directly get started with question number 1 for our today's session. A few strategies that in the last session we had discussed consist that we always need to replace any other variable with x and y in order to get its value. So in the last video, we had already discussed till question number 5. It's time to do question number 6. The question number 6 states that a circle in the xy plane has an equation this x plus 3 whole square plus y minus 1 whole square is equal to 25. Which of the following point does not lie in the interior of the circle? The meaning of the word interior means inside circle. Now, how are we going to do this question? Let's try to observe. We have the equation of circle, which is in the form of center radius form. Now, in the center radius form of circle, we know that center is nothing but minus 3, comma 1 and radius is nothing but 5 because in the center radius form, we always have x minus h whole square, y minus k whole square, and that's r square. So the value of radius is 5 here and the value of the center is minus 3 comma 1. We need to plot the circle as it is on Desmos and we will check which of the following options we have is not lying interior part of the circle. I'll open my Desmos. I'll try to write down the entire equation. X plus 3 whole square plus y minus 1 whole square equal to 25. Now, the Desmos has already shown us the circle. What was the question? The question was, out of the following given points, which one is does not lying in the interior part of the circle? One by one, we have to plot all the points and we will check minus 3, comma 7, minus 3, comma 1, 0, comma 0, and 3, comma 2. All right. So let's try to observe. In the last session, I have taught you that how you can locate any point on the graph. The first point you can clearly see 0, comma 0, which is lying in the interior part of the circle. So that cannot be your answer because they are asking which does not lie. Next, we have negative 7, comma 3 and negative 1, negative 3, comma 1. So negative 7, comma 3. Now, if I click on this label point, the point will be labeled for me. And that's one of the very cool feature of Desmos that you should definitely use. This is also lying in the inside, in the interior part of the circle. So that is not the answer. 3, comma 2 and minus 1, minus 3, comma 1. So if you see minus 3, comma 1, if I locate, this is also lying in the interior part of the circle. And again, if you observe 3, comma 2, you can also visualize this very easily, but yeah, just for the showing part, I am labeling that also, and I can clearly see that this point is lying outside the circle, and hence this is the final answer. So here we have discussed a very important feature of Desmos, which was the locate feature or label feature. That is how we can label any point on Desmos. Moving forward with the next question of our today's session, which of the following points do not satisfy the pair of inequalities given below? So we have these two simultaneous equations. In the last session, if you remember, in the very first part of the video, if you have seen that, we have discussed that any kind of simultaneous equations or inequations can be solved on Desmos. So these are our two equations. Let's try to plot it on Desmos first and we'll check the answer. The first equation we have is 2x plus 3y. I'll put greater than equal to 6. And I have 4x minus 5y less than equal to 20. Now, whenever we get these kind of solution, the solution which the common point which is there for us should be present in the common shaded part, as you can clearly see the red part and the black part. So whatever the solution will be should lie between this region. Now let's observe the points together. We have 2, comma 10, minus 2, comma 8, 2, comma 10. I'll label. Where is this point lying? It is lying in the interior part of this. So this will be considered as the solution. But they are asking in the question which do not satisfy, hence this cannot be the correct answer. We have minus 2, comma 8, 5, comma 30. Minus 2, comma 8. I can just change it here only. This is also lying inside, so that is not our answer. 5, comma 30. Let's try to observe. If we have to label this point is again lying inside, and we have the last point, which is negative 4 comma 10. This is also lying inside the shaded region. Minus 4 comma minus 10. The coordinate is minus 10. Now, as you can clearly see, the coordinate minus 4 comma minus 10 is not lying inside the common solution or the common region part. Hence, this is going to be our answer. Answer for this question is option number D. So here we have learned the very important thing that whenever you have the common region as this, then the solution will always lie from this common region. You can have some questions related such that the common region will be this, and they can ask you the maximum value of the y possible. And similarly, you can get this and this. So in that case, they can ask you the maximum value of x possible, and here maximum minimum value of x possible. All right. So now let's move forward with the next question. We have this kind of question and how this can be done on Desmos. Again, the very similar kind of question. I think you guys can do it now. Now, whenever we talk about the solution, again, the solution will be the point that will satisfy both of the given equation. But again, we don't need to do it manually because now we have the very powerful and interesting tool that is called as Desmos. So we are just directly going to plug in these two equations in the first tab and this equation in the second tab, and we will get the intersection point. Let's just quickly try to do it. I think that is easy. We can finish it up. Okay. The first one we have is x minus 2. And then we have x plus 4. The second one, we have a line which is y is equal to 6x minus 12. The moment you see, there will be an intersection point between the line and the parabola, which is 2 comma 0, and that will be your solution. Let's see in the question, 2 comma 0, we have our option number C as the solution. So there can be multiple cases. Let's understand about these cases first. In the case number 1, whenever you have a quadratic equation and a linear equation, your parabola and line can intersect at 2 points. In case number 2, your parabola and line can intersect at only 1 point. And in case number 3, your parabola and line can not even intersect. In this case, whenever we try to find out the discriminant, that should be greater than 0. In this case, that should be equal to 0. And in this case, that should be less than 0. What is discriminant? Discriminant is nothing. Whenever you have the standard form of any quadratic equation, you have b square minus 4ac as a value of the discriminant. All right, let's move forward with the next question, or the last question for our today's session, which is this one. The question says we have a function and the function g is defined by g of x is equal to f of x plus 5. This is just nothing but some modification and the same function has been done. And this has become a new function now. Now we need to find out for what value of x is g of x is reaching to its minimum. Now we already have the function f of x, which is 4x squared is plus 64x plus 262. Let's try to plot this function on Desmos and let's try to check the answer. The function f of x is nothing but 4x squared plus 64x plus 262. And then you have the next function, which is g of x is equal to f of x plus 5. Here you will learn a very important thing, which is the translation of graph. If I have to remove this and observe, I'll minimize the graph for you to look at both of the graphs. As you can clearly see, this is nothing, and this is the hiding feature of Desmos that I'll ask you to use a lot. Because to avoid any confusion, you can clearly see that this one is your initial graph and the blue one is your final graph. Now, it is nothing, but when your initial graph has shifted by how many units, you can clearly count. The x coordinate was minus 8 here and the x coordinate is minus 13. So clearly the parabola has been shifted by 5 units to the left. And that is how you can clearly observe that when x was equal to negative 13, the parabola, the new parabola, which is g of x, is reaching to its minimum. And that is how you can get the minimum possible values of x here. Hence, option number A would be your correct answer. So here we have discussed some very cool features again of Desmos, which is the hiding feature of any graph, which is again a very important, how to label any point. This is going to be very helpful in the upcoming questions where you were supposed to find out the center or the radius in the given equations of circle. So that wraps up around 4 to 5 questions for our today's Desmos practice session, everyone. The goal of this video was to help you feel more comfortable and confident using Desmos under exam conditions without overthinking the math. If you found this video helpful, make sure you hit the bell icon, like the video, subscribe the channel, and share it with your friends who is preparing for SAT. In the next part of this series, we will continue solving some more high quality SAT questions and strengthen your speed and accuracy even further. Until then, keep practicing, trust the process, and I'll see you in the next video. In the next video, we are more focusing on to creating some more parts of geometry. So if you want to learn geometry in detail, stay connected, stay tuned, and we'll be meeting you soon in the next video. Take care. Bye.